Hi everybody, welcome to physics teacher classes. Today we are going to discuss laws of motion, force and laws of motion. Already we discussed the force, different types of forces. Okay, right. Today we are going to discuss laws of motion. These also known as NLM or Newton's laws of motion also. We call this lesson as Newton's laws of motion or laws of motion simply. In different textbooks, different headings will come. Right. So, as I discussed, Sir Isaac Newton observed motion of different objects, and he concluded all his discoveries in three laws of motion. Okay, so those three laws of motion we are calling as simply laws of motion. So let us discuss first one, that is called first law of motion. First law of motion or Newton's first law of motion. Right, what is Newton's first law of motion? I'll give statement first, after that I'll explain. Listen carefully. Okay, every body continues in the state of rest, or of uniform motion unless an external force acts on it. An external force acts on it. This is Newton's first law statement, Nana. Okay, what is that? Every body, okay, you take any body, continues in the state of rest, okay, or of uniform motion unless an external force acts on it. Okay, so that means what does it mean? What is the meaning of this statement? Let us take an object which is at rest. Okay, the object is at rest. Okay, so every body continues in the state of rest. So if the body is in the state of rest, it continues its state of rest unless an external force acts on it. Is it correct or not? Let us see a chair. A chair is in the rest. Okay, until and unless it will be in the state of rest. Yes or no? So when you apply force on the chair, then its state changes. Understood? Right. Now the chair is in the state of rest. It will be in the state of rest only until you apply force on it. Yes or no? Similarly, if a body is in uniform motion, so uniform motion means already we discussed, speed of the body is constant. Okay, it will be in uniform motion until an external force acts on it. It continues, okay, and moves till infinite. Clear, Nana? Until an external force acts on it. Understood? It has two parts. One is it discuss about the rest of the body. Second one is it discuss about the uniform motion of the body. If a body is at rest, it will be in the rest only. If a body is in uniform motion, it will be in uniform motion only unless an external force acts on it. Clear? So this is Newton's first law of motion. Very easy. So from these two here, when the body is at rest, what can you say? You can say net force acting on the object is equal to 0. Yes or no? Okay. Here the body is at rest. Can you say no force is acting on it? No force is acting on it. Is this statement true or false? Yes, this statement is false. Why, sir? Here on the object, how many forces are acting? Already we discussed. Okay, out of 7, how many forces are acting? 2 forces. One is gravitational force. Always it acts vertically downward. Yes or no? Second one is, as these two surfaces are in contact, normal force acts. Okay, how many forces are acting here? 2 forces are acting. But the net force is 0. Understood, Nana? So when the body is at rest, you cannot say no force is acting on it. It's a blunder. Okay, when the body is at rest, net force acting on the object is 0. Okay, similarly, when a body is in uniform motion, net force acting on the object is 0. Clear, Nana? These two conditions you remember. Okay, when object is at rest, net force acting on the object is 0. When an object is in uniform motion, net force acting on the object is 0. From the Newton's first law, we can derive this. Right, now let us see another thing, that is inertia. What is that, Nana? Inertia. Right, so what is inertia? A simple definition I'll tell you. Inertia is nothing but inability of the body. What is that? Inability of the body to change its state. To change its state. That is called, simply we call as inertia of the body. Okay, it is nothing but not ability, inability of the body to change its state. Its state means it can be rest, or it can be uniform motion, or it can be state. Okay, direction also sometimes. No. So inertia is nothing but the inability of the body to change its state is known as inertia. That means if a body is in the state of rest, it tries to be in the state of rest only. Okay, don't want to change its state of rest. Similarly, if a body is in uniform motion, it don't want to change its state of uniform motion. It tries to be in the state of that. So in our language, we can say that is lazy. Okay, in human beings, everybody has a little bit lazy. Yes or no? Yes? Yeah. Similarly, every body has inertia. Every body. If it has mass, definitely it has inertia. And one more thing, people think that inertia is a physical quantity. It's not a physical quantity. Remember this, very important. Inertia is not a physical quantity. It is not a physical quantity like mass, length, time, temperature, force, like that. Okay, inertia is a not physical quantity. Then what is this, sir? It is the fundamental property of the body. What is inertia actually? Fundamental property of the body. Okay, every body has inertia, remember that. Every body. If it has mass, then definitely it has inertia. Okay, so how, sir? So if the body has more mass, it has more inertia. Remember this. Okay, similarly, if a body has less mass, then its inertia also less inertia. Okay, it is the fundamental property of the body by which it is inability of the body to change its state. Okay, if there is a huge body and a small body, both are in the state of rest, which have more inertia, definitely the more mass body has more inertia than the smaller mass. Clear? So this is the fundamental property of the body. It's not a physical quantity, remember that. Okay, sir? So here one more thing we can say, mass of the body measures inertia. Remember that. Mass of the body measures inertia. What does it mean? So by knowing its mass, we can tell its inertia. Okay, by knowing its mass, we can tell it. For example, let us take, there is a 2 kg body and 5 kg body. Which has more inertia? 5 kg body has more inertia. Understood? So then 2 kg body. Clear? Now you tell me there is a 10 kg body and 8 kg body. Which has less inertia? Which has less inertia? Compared to 10 kg, 8 kg has less inertia. Understood? So in this way, one can measure inertia by knowing its mass. Mass of the body measures inertia. Okay, inertia of the body cannot measure mass. Reverse is not true. Remember that point also. Right? So let us see more about inertia. So this inertia are of three types. How many types, Nana? Inertia, three types. Okay. So what are they? They are, one is inertia of rest. What is that? Inertia of rest. So what is meant by inertia of rest? Inertia of rest is nothing but the inability of the body, the inability of the body to change its state of rest, to change its state of rest. Simple. Okay, na? That means if a body is in the state of rest, it tries to be in the state of rest only. Okay, na, sir? Even though you apply force, it tries to be in the state of rest, like a lazy person. Okay, so that is known as inertia of rest. Simple. The inability of the body to change its state of rest. What are the examples of inertia of rest? Okay, now let us take a simple example. You are standing in a bus or in truck. Okay, this is at rest. When the bus or the truck at rest, you are also at rest. Yes or no? Right. Now the bus suddenly starts. Okay, then what happens to you? Yes, you might have observed you will fall back. Yes or no? Yes, this is the same situation when you are sitting on the bike at the back. Okay, when the bike suddenly starts forward direction, you will pulled back. Yes, so this property of our body is known as inertia of rest. What happens? What is our state here? Rest. What is our previous state? Rest. When the bus suddenly starts, our body tries to be in the state of rest only. Okay, understood? So but the bottom part of our body is connected with the bus, okay, or truck. It moves forward, so it is staying at the upper part is staying at the same position, so that it is moving forward, it is staying there only, so that it appears as pulling back. Okay, so this property is known as inertia of rest. Clear, Nana? So many examples. When you shake a tree, okay, na, sir, then what happens? The fruits will be falling from that. Why? Actually, the fruits and the tree are at rest. Yes, whenever suddenly you give a jerk to that branch, then what happens? So the stem is detached from that. So the fruit tries to stay in the state of rest only, but the stem is moving away, so that it is detached from that and falling down. Similarly, when there is a jerk given, okay, jerk given to the blankets or shirts, dust will be removed from that. Yes or no? Just will be jerking that, so that dust particles will be falling down. Why? The dust particles and the cloth is at rest previously. When you suddenly move the cloth, then what happens? The dust particles stay there only due to inertia of rest, and they will be falling down. Okay, these are the examples, many examples we can say. Next, second one is inertia of motion. What is that, Nana? Inertia of motion. This is the second type of inertia. So what is that? Similarly, the inability of the body to change its state of motion, is known as inertia of motion. Once again, what is inertia of motion? The inability of the body to change its state of motion. Okay, that means what? If a body is in the state of motion, it tries to be in the state of motion only. Okay, again let us take the same example, bus. Now the bus is in motion. Okay, you are standing in the bus. That means you also have motion. Yes or no? As the truck is moving, you are in the truck, so that you have motion. Now the driver of the bus applies suddenly brakes. Then what happens? You fall forward. Yes or no? Okay, you will be falling forward and hitting all the items which are placed in that. It may be front seat or something, front persons, you will be hitting them. Yes, so what happens here also? So what is your motion what is your previous state? It is motion. Yes, so your body is in motion. When bus suddenly comes to rest, what happens? What happens, Nana? So this part, the lower part is coming to rest, but the upper part is continuing its state of motion, so that you will be falling forward. Understood? So similarly, when you are sitting on the bike, okay, so the bike is moving. When he applies sudden brakes, okay, then what happens? You will be falling forward. On him, you will be pressing him. Yes? Yeah, certainly. Okay, so like this, we can see many examples of inertia of motion. Clear, Nana? Right. And the third one is, what is that? Inertia of direction. Inertia of direction. So what is that? Similarly, the inability of the body to change its direction of motion. To change its direction of motion. Okay, so the inability of the body to change its direction of motion is known as inertia of direction. Clear this one? So in this way we can define inertia of direction. Inertia of direction we can define. Now see here, examples. What are the examples, sir? Yeah, best. Again, you take the truck. Okay, you will be sitting or standing in the bus. It is moving. Suddenly there is a turn in the road. Okay, when the driver takes the turn, what do you feel? What is your feeling? Right, you will be falling on the sides of the bus. Yes or no? You will be falling to the sides of the bus. Yes, so that is because of inertia of direction. So your previous state is straight. It is in a straight line. So when the driver or the bus is turning, your body is supposed to move, supposed to continue the same direction. Even though the truck is turning, your body continues to be in the state of the direction of motion. Right? So that the body of human being or whatever it may be, it tries to fall. Right, Nana? So this is inertia of direction. One more example I'll give. So you might have seen, so the people sharpening the knives or axe, whatever it may be. Okay? They put on the wheel which is moving fast. They put the knives on the wheel. Okay, when you observe carefully, when they put the knife on the wheel, rotating wheel, the sparkings will come and move in the direction. Okay, this is also example of direction, inertia of direction. Okay, and you do one thing, you keep your bicycle in the water. Okay, and try to pedaling the bicycle by keeping it rest. Okay, when you pedaling, what happens? The back wheel will be rotating. Yes or no? When the back wheel rotates, the water rises up and fall down. This is also due to the inertia of direction. Okay, as the inertia of direction, the water rises up and falls. So during the rainy season, we see mud also will be coming up along with the back wheel. Right, Nana? So these are the examples of inertia. How many types of inertia are there? Very good, 3 types. So inertia of rest, inertia of motion, and inertia of direction. So this Newton's law we also call as a law of inertia. Law of inertia. Okay, Newton's first law is also known as law of inertia. It leads to define as inertia. Okay, so one more thing, important thing already we discussed, inertia is not a physical quantity. Right, Nana? It's a fundamental property of the body. Clear? So from Newton's first law we define 2 things. One is when the object is at rest, it tries to be in the state of rest. When the object is in uniform motion, it tries to be in the uniform motion only. Okay, so that means when the object is at rest or in uniform motion, net force acting on the object is 0. Clear? Very good. Now let us learn second law of Newton. What is that? Newton's second law. Before going to learn Newton's second law, let us define another physical quantity, momentum. What is that, Nana? Momentum. We need to define this. This is denoted by P and it is a vector physical quantity. Momentum. Okay, momentum is nothing but simply mass in motion. Simply mass in motion. So how to define this? So the definition of momentum is the quantity of motion contained by a body. What is that, Nana? The quantity of motion contained by a body. Okay, by a body. This is known as momentum. It's a definition. Okay, so how to define momentum? Simply the quantity of motion. How much amount of motion it contained. Quantity means amount of. Okay, so that is called what, Nana? Momentum. So first, why should we define momentum? Because there are many physical quantities in physics. What is the need of this momentum again? Okay, so mathematically, momentum is defined as a product of mass and velocity. Okay, it is the product of mass and velocity. Velocity is a vector and mass is a scalar. We are multiplying a scalar with a vector, so that we will be getting another vector physical quantity. Then why we need to define this? So let us see some of the examples. Okay, let us have two objects. Okay, let us have two objects. Both have same mass. Let us take. Both have same mass, and one is moving with the velocity v1, another one is moving with velocity v2. Okay, na sir? Right, this is one situation. Now let us see another situation. There is two objects. There are two objects. One is moving with 2 meters per second. Another one is moving with 200 meters per second. 200 meters per second. Now these two objects hit another object, for example. Okay, let us take, this is a wall. Okay, now these two objects are moving and hitting the wall. Now tell me which object applies more force on the wall. Which object applies more force on the wall? Can you tell? No, we cannot tell. Okay, by knowing only its velocity, we cannot tell. Yes or no? Right, let us take, this is a lorry and this is a bullet. Can you tell? Right, so that means by only observing their velocities, okay, we cannot identify how much force they apply. Right, similarly, by knowing only its mass, for example, let us take this mass is 2 kg and another mass is 200 grams. Let me take. Now both are hitting a wall. Can you tell which is applying more force? No. Okay, because I may take this as a bullet and I may take this as a lorry or any stone. Okay, na? So that means by observing only their masses also we cannot tell. Okay, when these two are combined, understood? When these two are combined, then only we will get an idea which object is applying force. Understood? So for example, I take a 2 kg object which is moving with a speed of 1 meter per second, or another object I take which has 20 kg and moving with a velocity of 2 meter per second. Now I can tell which has apply more force. Okay, sir. So that's why another physical quantity is discovered, is introduced simply. Okay, that physical quantity is the product of mass and velocity that we are calling as momentum. Understood, Nana? So now what is the mathematical formula of momentum? Already we have seen the mathematical formula of momentum is P is equal to, what is that? P is equal to mass into velocity. Okay, now, so this is the formula to calculate momentum. Next, what is the unit of momentum? Okay, very simple. In physics, we know, if you know the unit formula, you can write a unit. So first in MKS, what is that? Kilogram into meter by second. Kilogram into meter by second. Next in CGS. Okay, in CGS system, what is that? So in CGS it is a gram centimeter per second, because unit of mass is gram, velocity centimeter per second. Okay, na? So in SI, what is the unit? Okay, so in SI also we can take kilogram meter per second. Clear na? So some other units will come that I will discuss later. Okay na? So this is about momentum. Okay, now momentum is mass in motion or the quantity of motion contained by a body. Okay na? So its mathematical definition is product of mass and velocity. So its units are kilogram meter per second, gram centimeter per second. SI also we can take this one, right? Now, and it is vector quantity. Then what could be the direction of momentum? The direction of momentum will be in the direction of velocity. Clear na? The direction of momentum will be in the direction of velocity. Now let us see Newton's second law. Newton's second law or second law of motion. Second law of motion. Right. So the second law of motion is defined as the statement is the rate of change in momentum. The rate of change in momentum of a body is directly proportional to net force acting on the object. Net force acting on it simply. Okay, what is that, sir? The rate of change in momentum. Which rate? It is time rate of not momentum, change in momentum is directly proportional to what? Net force acting on the object. Okay, suppose let us take an object of mass m is moving with an initial velocity u. Okay, after traveling some distance. Okay, so a force is acting on it at a time 0. A force F is acting on it. It travels for time t. After time t, its velocity becomes v. Okay, because a force is acting. When force acts, the velocity of the body is supposed to change. Okay, now let me tell what is the initial momentum in this case. What is the initial momentum? Initial momentum is nothing but initial mass and initial velocity. What is the initial mass? M into what is the initial velocity? U. Okay, next, what is the final momentum? Final momentum. So that is final mass and final. In this case, mass is not changing. Sometimes mass also will change. Be careful. So in this case, final mass and final velocity. Final mass is m and final velocity is v. Okay, now what is a change in momentum? Change in momentum. Okay, that is change means what? Always final minus initial. Okay, now rate of change in momentum. Rate of change in momentum. I am writing delta p. Delta p is nothing but change in momentum. That is mv minus mu divided by time rate. Okay, this rate of change in momentum is directly proportional to net force acting on the object. What is the net force acting on the object? Here only there is a applied force F. Therefore, F net, okay, is equal to mv minus mu by t. I can write. Okay, na? Right. So from this I can write F net. Okay, F net is equal to m of v minus u by t. It can be written as how, sir? F net. Net force acting on the object is m into a, because v minus u by t is a. Okay, so this is the mathematical formula of Newton's second law. F is equal to ma. Here F is net force acting on the object, means total force acting on the object. Okay, so this is one kind of explanation of Newton's second law. So the actually what is Newton's second law explanation is here F net, okay, is directly proportional to rate of change in momentum is nothing but d by dt of p. D by dt of p. Okay, for eighth standard, 7th, 8th standard, this is the thing you need to remember now. Okay, so F net is equal to MA. For above 9th class, 10th class and above, let us see this. After this statement, you need to follow this. So here F net is equal to d by dt of P. Okay, it is nothing but in mathematics you might have learned this is differentiation. Okay, so if you know differentiation, then follow this. Otherwise you can follow this, no problem. Right, so from this again we can write F net is proportional to d by dt of P means mu. Okay na, mass into velocity. Here two cases are possible. Okay, so what are the first this F net what I am writing is equal to, okay na, so formula d by dt of u into v is m into dv by dt, okay, plus v into dm by dt. Okay na, see this F net is equal to what, m into dv by dt plus v into dm by dt. Right, here case 1. In this case 1, mass of the object is constant. In the previous case we have seen, is mass changed? No, mass m and m, but the velocity has changed. So if mass is constant, what happens to net force is that is equal to m into dv by dt plus v into d by dt of constant value is 0. d by dt of constant value is 0. Therefore, what do you get is in this case F net is equal to m into dv by dt, means rate of change in velocity. It is acceleration. Okay, clear? This is case 1. What about case 2? Case 2 is nothing but here velocity is constant now, but the mass is changing. Okay, this is called a variable mass system. What do you call this as? Variable mass system. Now in this case, what happens to F net? F net is equal to m into dv by dt. As v is constant, this will be 0. Differentiation of a constant value is 0. This will be 0. Therefore, v into, what is the formula? dm by dt. Okay na? So this is the formula used when mass is changing. Okay, this is applicable for variable mass system. Remember this. For variable mass system we apply this. Okay, is there any example of variable mass system? Yeah, there is an example. Okay, what is that? So I will give one example. So there is a conveyor belt. What do you call this as? Conveyor belt. Or else you might have seen in airports. So there is a belt that is moving. On that belt you keep your luggage. Yes or no? Yes. See, you observe here, this belt moves with a constant speed. Okay, but you will be adding mass on that belt. Means here mass is changing. Okay, the engine need to apply a force on the belt. Okay, that will be equal to v into, means constant speed of the belt into changing mass. How much it is changing in time. Okay, for example, in unit time it is changing 2 kg. 2 kg per second. This is a change in the mass. dm by dt value is 2 kg per second. Then 2 kg per second into constant speed 2 meter per second or 3 meter per second. If you multiply, you will be getting how much force the engine need to apply on the conveyor belt to maintain the constant speed. Understood? This is a variable mass system. Here the mass is continuously changing. So previously I said one more thing. What is that? Okay, there is another conveyor belt. From this, coal will be falling here. A coal is dropped from the chop here. Continuously coal is falling on it, but the belt is moving with constant speed. Then how much force is applied by the engine to maintain the constant speed? Okay, coal is falling on that continuously. Okay, so this is also variable mass system. Another one is a rocket. when the rocket is moving up in the space, okay, what happens is, first thing is, its fuel will be consumed. Means its mass is decreasing or not? Mass of the rocket is decreasing? Yes. Secondly, the parts of the rocket will be detached and fall. Okay, so that the mass will be decreasing, so that it gives acceleration to the body. Understood? These are all the variable mass systems. So in some cases you can see both will change. What? Mass and velocity. When there is a change in the two things, then this is the formula you need to use. F net is equal to m into dv by dt plus v into dm by dt. If mass is constant, this is the formula. If velocity is constant, this is the formula. Understood, Nana? Right. This is Newton's second law of motion. So for small children, okay, 6th class, 7th class, I can give one more thing. The net force acting on the object, okay, is directly proportional to acceleration, or the acceleration produced in a body. For example, this is the body. On this body we applied a force. It gains an acceleration. The acceleration produced in a body is directly proportional to net force acting on it, and the same acceleration produced in the body is inversely proportional to mass of the body. Okay, that means, see here, you take a small object and a big object. On these two you apply same amount of force. Okay, so in which case you will get more acceleration? Right, in this case there is a bicycle, Nana, and a car. On these two you are applying same force. Which moves faster? Bicycle, as its mass is less. Okay, so its acceleration is more. A is inversely proportional to m. By combining this you can write F net is equal to ma also. That is also you can follow. No issue. Right, Nana? Okay, this is about Newton's second law of motion. Clear?